All right, welcome to Max and Min's Applied Electronics example number 3. All right, here is the problem. Find the greatest current in an 8 microfarad capacitor if the applied voltage is V equals 250 T squared minus 200 T cubed. All right, so the question is specifically looking for the greatest current in the capacitor. So we know from previous studies that IC capacitor current is equal to C dV dt. Now the problem gave us the voltage in terms of T. So if we take dV dt and we get 500 T minus 600 T squared. Now if we set that equal to 0, we know that that's going to be our greatest capacitor voltage. That's where our voltage is going to, our slope is equal to 0, and we can solve for T equaling 833.33 milliseconds. So now with the T, we can put the T back into the original formula and solve for what the maximum voltage is going to be on the capacitor at that time. And you can see I plotted the original formula into Desmos with the calculated data points where our time is equal to 833 milliseconds and our voltage is equal to 57.8704 volts, and we can see that that is in fact the max voltage for the capacitor. But the question isn't exactly asking for what is the time for max voltage or what is the max voltage. So one thing to think about, okay, so if we take that time and put it back into the formula for IC, so IC is equal to C dV dt, we see that if we put 833 milliseconds into that formula, we get IC is approximately equal to 0 at that time. And that makes sense because as a capacitor becomes fully charged, as it's approaching that full charge, that full voltage, the current should be going down. And so that is kind of represented here in this question. So when we solve for the max voltage, we ended up solving for the actual minimum current, or the time it would take to reach full charge. So how are we going to find the greatest current in this question? So we've got our IC, we know IC is equal to dV dt. So if we take the derivative of V, we get the 500T minus 600T. So we can now take the 800 microfarads and multiply that through, and we've got an IC equals in terms of T. So we've got I and T now. And that's what the original question was, what's the greatest amount of current? So if we take the derivative of that and then set that equal to 0, we can solve the time. There's the time it takes to get to the maximum amount of current for the cap, 416.667 milliseconds. So now that we have the time, 416.667 milliseconds, we can put that back into our current formula and solve for what the max current is going to be at 416.667 milliseconds. You can see we get 833.333 microamps at that time. And here's a graph in Desmos where I've plotted the current formula, and the two data points, the time 416.667 milliseconds versus the 833.333 microamps, and we can see that that in fact falls or lands on our curve, and it's at the max point. Okay, so this slide is showing, I'm matching up the x-axis on the comparing voltage and current for the capacitor. And you can see when the voltage is at the max, our current is at 0, bottoms back out. And that our maximum current is somewhere in between those 2 points, and we've got 833.333 microamps at time equals 416.667 milliseconds, and our max voltage is at 833.333 milliseconds.